Jai Hind students. Students, never be afraid of failure. Actually, learn from your failure. Once you have committed a mistake, never try to repeat it. Rectify your mistakes. A winner always tries to make a transition from total helplessness to independence and interdependence. So students, with that, let's start this particular session. In the previous lecture, what we have discussed was motion of charged particle under the influence of electric field as well as under the influence of magnetic field. And we have discussed about magnetic Lorentz force as well. That is the force experienced by a moving charged particle under the influence of magnetic field. So these are the questions related to the taught topics which we have done in the previous lecture, right? So let's begin with the first question. First question is, students, a proton is moving with a velocity of 10 to the power 6 meters per second towards east, right? Under the influence of magnetic field of 3 Tesla, which is directed towards north. Find out the magnetic force. So magnetic force being a vector quantity, its magnitude as well as direction needs to be determined, right? So let's indicate with the help of this particular diagram. Suppose this is north, this is south, this is west, and this is east, and this is the vertical direction, right? So a proton is moving with velocity of 10 to the power 6 meters per second due east. So this is the direction of motion of the positively charged particle proton under the influence of magnetic field of 3 Tesla directed towards north. Okay, it is directed towards north. This is the direction of the magnetic field. So students, angular name is 90 degree, and we are aware F vector, it is equal to Q V vector cross B vector, isn't it? So this is the cross product. So V cross B, let's get the direction of V cross B. Angle is to be measured from V to B like this, east to north like this. So thumb is pointing in the upward direction. So this must be the direction of V vector cross B vector, which is perpendicular to both the direction of the magnetic field as well as the direction of the motion of the charged particle, right? So this is V cross B. Now look students, proton being a positive charge, therefore F vector will be directed along the direction of V vector cross B vector because Q is positive over here. So this is the direction of the magnetic force. This will be the direction of the magnetic force. So in which direction this magnetic force acts? It will act in the vertically upward direction. Therefore, direction of the magnetic force is vertically upwards. So we have determined the direction. Now let's find out its magnitude. So magnitude, it will be given by Q VB, the angle between the velocity vector and the magnetic field vector is 90 degrees. So it will be sine 90. So it is QVB, right? Sine 90 is 1. Let's substitute the value. Proton, it carries a charge of plus 1.6 into 10 to the power minus 19. Velocity of the proton, that's 10 to the power 6. Magnetic field, the strength of the magnetic field, it's given to be 3, isn't it? So what we get is 4.8 into 10 to the power minus 13 Newton. And direction we have already determined. The direction of the magnetic force is in the vertically upward direction. So that is how you need to proceed. You need to first find out the direction of V cross B using the property of vector product and using right hand thumb rule. And in case the charge is positive, then magnetic force would be along the direction of V cross B. In case charge is negative, then force would be in a direction opposite to that of V cross B, right? So we are over with question number 1. Let's concentrate on question number 2. Question number 2, an electron is moving with velocity of 10 raised to the power 7 meters per second northwards under the influence of magnetic field of 10 Tesla directed upwards. Again, we are supposed to find out the magnetic Lorentz force. So its direction as well as magnitude is to be determined, right? So it has to be represented diagrammatically first, right? So let us draw the appropriate diagram now. This is north, this is south, this is west, this is east. And suppose this is the vertical direction, right? This is the reference point, point 2. Electron is moving with this velocity northwards. So this is where the electron is moving, right? Under the influence of magnetic field of 10 Tesla, directed upwards. This is the direction of the magnetic field. This is the direction of the magnetic field. Now we are aware, students, F vector is equal to Q B vector cross B vector. Now this is the case of an electron. So in case of an electron, it's a negatively charged particle. It carries a charge of minus 1.6 into 10 raised to minus 19 coulomb. So it should be actually minus E V vector cross B vector. So let us first find out the direction of V cross B, and then the direction of the force would be opposite to the direction of V cross B because of this negative sign over here, right? So V cross B and F vector, they should be oppositely directed, electron being negatively charged particle. So let's find out the direction of V cross B. This can be found by using right hand thumb rule. V cross B, like this. The fingers should curl along the direction from V vector to B vector, right? This is how. So it is directed towards east, isn't it? It is directed towards east. So this will be the direction of B vector cross B vector, right? It is perpendicular to both B vector as well as perpendicular to B vector. Again I repeat, students, the direction of V cross B, it is given by right hand thumb rule. The direction in which the fingers curl, that gives the direction of the orientation of the vector V vector to B vector, right? This is north, this is south, this is west, and this is east. So north to vertically upward action. It will be like this. So thumb is pointing towards east. Therefore, the direction of V cross B is towards east. Now, what will be the direction of magnetic force? Concentrate over here, students, this negative sign. This negative sign suggests that magnetic force is in a direction opposite to that of V cross B because of this negative sign. So if V cross B is directed towards east, then the magnetic force would be directed towards west. So this is where the magnetic force must be directed. Obviously, it should be also perpendicular to both velocity vector as well as magnetic field vector. So direction of magnetic force is towards west. So this is one part of the answer. Direction we have determined. The magnetic force is directed towards west, right? Now let's find its magnitude. So magnitude, we are aware, magnetic force, it's given by Q V vector cross B vector. We are concentrating only on the magnitude. Charge of an electron, that is 1.6 into 10 raised to minus 19. We are dealing with the magnitude only, right? Direction we have already discussed. V, velocity, magnitude is 10 raised to 7. Magnetic field, strength of magnetic field is 10. And the angle between these two is 90 degree, right? So it will be sine 90. Sine 90 is obviously 1. So it will give us 1.6 into 10 raised to minus 11 Newton. And direction is towards west. So this is the complete answer. Convinced, students? It's very simple. You need to draw the appropriate diagram and you need to apply the rule, that is Fleming's right hand rule, so as to determine the direction of V vector cross B vector. And depending upon the nature of the charge, whether it is positive or negative, we can easily determine the direction of the magnetic force. Clear, students? So we are over with question number 1 as well as question number 2, right? Okay, let's proceed towards question number 3. A charged particle of 2 coulomb is moving with velocity of 2i cap plus 3j cap meter per second under the influence of magnetic field, which is again given in rectangular components, 3i cap plus 2j cap Tesla. We are supposed to find out the magnetic force, right? So let's write down the given data. Charge, it's given to be 2 coulomb. Velocity in the vector form, it's given to be 2 I cap plus 3 j cap. It's in SI, meter per second. And the strength of the magnetic field, it's given to be 3 I cap plus 2 j cap. It's in Tesla. We are just supposed to determine Fm, right? So students, this is the formula. Fm, it's equal to Q V vector cross V vector. This being positive charge, so it will be directed along the direction of V vector cross V vector. This is the cross product. So first consider the cross product. Right? Let's find out its value. Okay. It can be written in the determinant form, isn't it? You must have done it in your junior class as well. So first we are supposed to write the coefficient of I cap, j cap, k cap of velocity vector. Right? So V vector, coefficient of I is 2, coefficient of j is 3, coefficient of k, it's absent, so it is 0. Now we are supposed to write the coefficient of I cap, j cap, k cap of magnetic field vector. It is 3, 2, and again k cap, it's absent, it is 0. Right? Let's solve it. I cap this into this minus this into this. So 3 into 0 minus 2 into 0. The middle term, it will be negative minus j cap. This into this, right? So 2 into 0 minus 3 into 0 plus k cap 2 into 2 minus 3 into 3. So what we get is 0 I cap minus or plus 0 j cap minus 4 minus 9, that will give us minus 5 k cap. So students, V vector cross V vector is equal to minus 5 k cap. Right? So what is the direction of V cross V? It is minus k cap. K cap is the unit vector which represents the direction of z axis. So minus k cap will represent the direction towards negative z axis. So since it is positive charge, therefore Fm is directed along the direction of V cross V, which is towards negative z axis. So this is the direction of the magnetic force, right? Now let's get its magnitude. We are aware force, it's given by this formula, Q V cross V. Now since we have obtained the value of V cross V, now let's get its magnitude. So what we do is Fm in magnitude. It will be Q V B, or rather V cross V. Just we are concentrating on its magnitude, right? Now in the vector form, V cross V is minus k cap. Therefore its magnitude would be, students, you are aware, it's equal to square of the coefficient of I cap plus square of the coefficient of j cap plus square of the coefficient of k cap. So here magnitude would be 5 units only. Let me verify it. So it will be coefficient I cap is j, coefficient of j cap is 0, coefficient of k cap is minus 5. Right? So what do you get? It will be equal to 5 units. This is the magnitude. So Q, it is 2 coulomb. Magnitude of V cross V, it is 5 units. So it is 5. So it will be equal to 10 Newton. And direction, it will be towards negative z axis, as it is given by minus k cap. Right, students? So here we have made use of the properties of the vector product or the cross product. Right? So we are done with question number 3 as well. Okay, let's proceed to question number 4 now. This is an interesting question actually. Question 4 is a proton and an alpha particle. I repeat, a proton and an alpha particle, both possessing equal kinetic energy, enters a region of uniform magnetic field in a direction perpendicular to it. We are supposed to compare the radii of the circular paths followed by these two particles, right? Student, first point is, we are aware, we have done it in the theoretical section, that whenever a charged particle enters a uniform magnetic field in a direction perpendicular to the magnetic field, then it always tends to follow a circular path. Right? It always tends to follow a circular path. And the radius of the circular path followed by the charged particle is given by mv divided by qb. So this is the formula to be used over here. Right? Here there are two particles. One is proton, the other one is alpha particle. Let us consider this to be 1 and this consider to be second particle 2. Right? So now proper way of representing proton is H11. Alpha particle is represented by helium nuclide He42. Therefore, what about mass? If its mass is m, its mass will be 4 times the mass of proton. Clear, students? Similarly, what about charge? If the charge on a proton is q, then the charge of the alpha particle would be twice q. Am I clear? This should be known to you. It is only then you will be successfully able to attempt this particular portion. Right? These are the basic facts which you are already aware of. Now we are supposed to find out the ratio of this radius of the circular paths followed by proton and alpha particle. So we are supposed to find R1 is to R2. So R1 would be M1 V1 divided by Q1V is to M2 V2 divided by Q2V. B is same in both the cases. Why? Because both enters the same uniform magnetic field. B is constant. And one more information is given, students. It is given that both possess equal kinetic energies. What I mean to say is that it is given that half m1 v1 square is equal to half m2 v2 square. Clear? It is equal to E, say. This is kinetic energy and it is given to be constant. So what we get is m1 v1 square is equal to m2 v2 square is equal to twice E. Clear, students? So what we can do is basically we can make use of these facts over here as well. Velocity v1, it can be written as square root of twice E by m. Similarly, v2, it can be written as square root of twice E divided by m2. Am I clear, students? Simply substitute the value of v1 and v2 over here and then it should give us the ratio of the radius of the circular paths followed by proton and the alpha particle. So let's proceed. Kinetic energy as per the question is given to be constant. So what you get is R1 is to R2. It would be M1 divided by Q1. B and B, it is constant. It will get cancelled out. In both the cases it will be same. V1 can be written as square root of twice E divided by M1. And over here we will get M2 by Q2 and this is 2E divided by M2. So let's simplify this, right? Root 2E get cancelled out. So this can be written as 1 by Q1 and square root of M1. Now look, M1 can be written as root M1 multiplied by root M1. One of this root M1 will get cancelled, so we will be left with root M1 in the numerator, right? Similarly over here, we will be left with only square root of M2 divided by Q2. Let's substitute the value now. Okay, M1 is equal to proton. For proton the mass is M divided by Q1. Q1 is Q is 2. This is the ratio. Square root of M2. M2 is the mass of the alpha particle, which in terms of M is 4M, 4 times the mass of proton. Divided by Q2. Q2 is twice Q. So what do you get? Therefore, R1 is to R2 is equal to the solve it. Square root of 4, that will be 2 to get cancelled. So root M by Q is to root M by Q. So that will give us 1 is to 1. So students, this is the answer. So as per the given situation whereby the proton and the alpha particle are considered to be possessing the same kinetic energy and they enter a uniform magnetic field in a direction perpendicular to it. So in such a case, both will follow circular paths and that too of same radius. That is what we obtained. The ratio of the radius of the circular paths followed by these particles is 1:1. Right? So this was a good question. Let's practice another similar question. Right? Here there were two particles, proton and alpha particle. In the fifth question, students, a proton, a deuteron and an alpha particle, all possessing same kinetic energies, they enter a region of uniform magnetic field in a direction perpendicular to it. So it is but obvious that all the three particles will tend to follow circular paths. So here we are supposed to find out the ratio of the radius of the circular paths followed by these three particles, proton, deuteron and alpha particle. So we will follow or we will proceed to question number 5 in this similar fashion, right? So let's do it. So question number 5, let me again read it for you. A proton, a deuteron and an alpha particle, all possessing equal kinetic energy, enter a uniform magnetic field at right angle to it. Find the ratio of the radius of the circular paths followed by the particles. Right? Okay. First and foremost, these are the three particles. Proton, second one is deuteron, and third one is alpha particle. Let us consider this to be the first particle, this one is second, and this one is third. Now, as we are aware, proton is represented by H11, deuteron, it's an isotope, H21, alpha particle represented by helium nuclide, He42, right? So, what about mass? If its mass is considered to be m, its mass will be twice m and its mass will be 4 times the mass of proton. And what about charge? If its charge is considered to be q, then deuteron will also have charge q, while alpha particle will have charge given by twice of the charge possessed by proton, right? Okay, this is done. Now also it is given they all possess equal kinetic energies, that is half m1 v1 square, it's given actually, is equal to half m2 v2 square is equal to half m3 v3 square is equal to E, say. And it is constant, half gets cancelled out. So v1, it can be written as square root of E by n or twice E by n. You can write it like this, twice E by m1. Similarly v2, it can be written as square root of 2E by m2. And v3, it can be written as square root of twice E divided by m3. Right, students? Now we need to compare the radius of the circular paths followed by these particles. That is, we are supposed to find R1 is to R2 is to R3. So what's the formula for the radius of the circular path followed? It is mv divided by qb. That's the master formula. It is mv divided by qb. It will be m2v2 divided by q2b. One thing should be noted down, magnetic field, it's uniform. So in all the three cases it will be same. So it is m3v3 divided by q3b. Now let's substitute the value v1, v2, v3 over here, right? B is common. So what do you get is m1 by q1, v1, that's root twice E divided by m1. So m2 by q2, square root of twice E divided by m2. And over here we get m3 by q3, square root of twice E divided by m3. On further simplifying it, what we get is root m1 by q1 is to root m2 by q2 is to root m3 by q3, which will give us root m1 by q1. So over here, m by q, it will give us root m by q is to root m2 by q2, that is root 2m divided by q is to root m3 divided by q3. m3 is root 4m. Root 4m divided by q3. q3 is twice q. Right, students? So, root m by q, root m by q, root m by q is common. So, what we are left with here is r1 is to r2 is to r3. It will give us 1 is to root 2 is to root 4 by 2. That in turn will give us 1 is to root 2 is to 1. So students, this is the ratio of the radius of the circular paths followed by proton, deuteron and alpha particle on entering a region of uniform magnetic field in a direction perpendicular to it. So the answer is 1 is to root 2 is to 1. So students, we have done all the 5 questions. I hope you have understood the concepts behind these questions, right? Feel confident while doing these questions. Once the theoretical concepts are clear, then there shouldn't be any problem in solving these straightforward questions, right? So that's it for this particular session. Do join me in my next lecture then. Till then, goodbye.